Hey everyone, welcome back to my channel. Today in this video, we will be exploring the concepts of debugging. If you don't know what debugging means, in simple terms, it is the process of finding bugs and errors in a program. And the tools that are used for debugging purpose are called debuggers. And there are many debuggers. GNU GDB is one of them, which is used for debugging C and C++ programs. And there are other debuggers like LLDB debugger, Visual Studio debugger, and there are some other debuggers which are specific to particular IDE. Next, let us explore some important terminologies that are used in debugging. The first one being the breakpoint. It is the point where our code should be paused. And second term is watch variables. These are the variables whose value we want to track as our program progresses. And for flow control, we have four important terminologies. Continue means to go from one breakpoint to another breakpoint. Step over means as simple as going to the next line. And step in is also similar to step over, but in case of function call, step in will take us inside the function. So that is the difference between step over and step in. And step out is opposite to step in. Once we have stepped into the some function and now we want to go back to the calling function, then we will execute step out command. So let us see this in our code. So this is a program for sorting an array. The algorithm is bubble sort. So suppose now I want to pause my code here in this line number 26. So I'll have to mark it as a breakpoint. So after the array has been initialized and before the bubble sort function is being executed, I want to see the state of my array. So for that I want to pause my code on line number 26. So I'll set this as a breakpoint. Next, after I want to see my array after the array has been sorted. So I'll keep this line number 28 as the breakpoint. So here the array will be initialized and the code will be paused on line number 26. And if we do next or step over command, the code will come on line number 27. And again if we do next or the step over command, the code will come on line number 28. So in line number 28 we can see the sorted array since this bubble sort has been called. So these are breakpoints. And if we execute for flow control, if we execute continue, suppose I'm starting the program, so the program will pause on the very first breakpoint, which is line number 26 in our case. And if we execute continue from line number 26, the code will now pause on line number 28. The line number 27 will be executed, but it will not pause anywhere here. It will all execute and next it will pause on the next breakpoint. So continue means to go to the next breakpoint. Step over means to go to the next line. Step in also similar to step over. It also means going to the next line, but in case of function call, it will take us inside the function call. Suppose the code is paused on line number 26, and now if we execute step in command on line number 27, it will take us inside this bubble sort function here on line number 5. So these are the important terminologies. Now let us see directly in the code. Now let us jump into the code. So this is the code that we will be using today to learn the concept of debugging. This is a program to sort an array and the algorithm is bubble sort. So if you don't know about this how bubble sort algorithm works, don't worry, that is not the purpose of today's video. And now let us quickly go through the program. Our main will start on line number 24. After that we will be initializing an array with 5 numbers 5, 4, 3, 2, 1 and calculating the size. And after that we'll call this bubble sort function and pass this array and size of the array as parameters. Now here the algorithm will execute. We will not worry how the algorithm is working, but the purpose is to sort the elements in ascending order. So we expect the output to be in sorted order. So the output will be 1, 2, 3, 4, 5. So that is the quick overview of this program. So now let us go and compile it first. In order to compile, we have to use this command g++-o and the name of the output file and the source input, and -g for keeping the debugging flag. And this is the command for compiling C++ program. And for C programs we can use this command. We have to use gcc and other things are same. So this program is written in C++. So let me use the command for G++ -o, and the name let me keep as bubble, and the source file is bubble.sort.cbp. And in order to keep the debugging flag, we need to give -g flag. So now the program has been compiled. Now we need to open it in GDB. So GDB and name of this binary, so bubble. So this is the basic interface of our GDB, and since this is entirely a command based debugger, we have to execute commands to set breakpoints and to jump to continue, and whatever things we had seen. For doing all these things, we have to make use of command. So we can take help using help command. Now let us quickly explore some other aspects of this GDB. So this is where we give the command, and once we hit enter, the output will come here. So one thing, next thing that I like to show is the layout. So if we do lay n or lay next, it will take us to different layout. So in this layout, it will show the corresponding assembly code, and this is for executing the commands. And we can go to other layouts as well, and this is like source view, the assembly view, and the command view. We are not interested in this assembly code, so let us go to some other layout. Not even this, yeah, this is the compatible layout for us, since we are interested in the source code and only executing in command. So the name of this layout is src, or the source layout. So we can directly come to this layout by executing lay src. So now let us start by doing the first thing, which is to set the breakpoint. In order to set the breakpoint, we have to use the command break and then line number, break line number, or we can even give the name of the function. So in case of C++ program, it is very common to start giving the main function as the first breakpoint. So let us do that. So we'll do break main. So here you can see the B plus symbols. This indicates that our line number 24, which is the starting of our main function, has been set as the breakpoint. So as stated in here, let us set the line number 26 and 28 as our breakpoint. So we can do that by using break line number 26 and break line number 28. So other options that we have is we can clear the breakpoint by doing something like clear, and in the same way we can give function name as well as line number. So let us try clearing the line number 24, the main function, as let us remove that breakpoint. So you can see here the breakpoint marker has been removed. Since we are interested in breaking there, so let us break on line number 24. So after setting the breakpoint, now we have to start the program. In order to start the program, we need to give run command. So here you can see that our code has been started, and it has been paused on line number 24, and you can see this symbol has been capitalized. So this indicates that we are at the breakpoint, and this is the point where our code is paused. Others have not been capitalized. So now in order to go to the next line, we will execute next command, which means step over. So if I do next, you can see here the code has been paused on line number 25. Now if I do next, again the code will go to line number 26. If I do next, the code will go to line number 27. So this is the step over function, and it is executed using next command in GDB. Now let us see the other control flow commands. So for that, let us rerun the program. Yes, okay, now the code has been paused on line number 24, and I don't want to stop my code on line number 25. I want to directly go to the line number 26. So for that, we'll use continue command. So you can see here the code has been paused on line number 26, and again if you execute continue command, the code will go to the next breakpoint, which is line number 28. So this is about continue. Next we can do is what we can do is step in. So let us restart the program again, and let me do continue to go to line number 26. Now if I do si, or step is the command that we can use in GDB to perform step in operation. So if I do step in, it will go to next line, means line number 26 was not a function call, so it normal it went to line number 27. Now if we do step command, it will take us inside the function call, you can see here. So this is how we execute step in instruction in GDB. So other instructions are we saw continue, step over, step in, and okay, now step out. Now if we do, now suppose I have done the debugging operations here and I figured out my mistake or the bug in my program. Now I don't want to run this loop again and again. So now I want to step out from this function. For that we can give the command as finish finish. So you can see here now the code has come out of this function and has been paused on line number 28. So that is how we do step out function. And I'll show you was variables. Was variables means suppose okay, let me come inside this bubble sort function first. Let us restart our program and let me go to the line number 27. So continue for going to the line number 26. Next, now I'll do step in to go inside the function. Now I want to track the value of I and j variables here. So for that I have to use watch and the name of the variable, which is I, and also I want to track the variable j. So watch j. Now as soon as their value is changes, you can see the old value and new value here. So this is helpful if you want to monitor some variable very closely. So that is how we set watch variables in GDB. Till now we just explored those commands and saw how those commands actually work. Now let us genuinely debug this program in order to grab the genuine flow when we are debugging in real. So let us start from the beginning itself. So I have debugged that, I have compiled that program, and let us start our debugger GDB and pass this binary. So the GDB has started. Now we need to choose the right layout for us. So source layout is something that we want, so let us execute lay src. So we are directly switched to the source layout. And another thing that we may do normally when we are debugging is we may want to change the height of these command windows. So for that we can do something like win height and the name of the window src, and we can give some absolute value like 20, or maybe depending upon your convenience, win height src 15. So let us keep it like this. And one other command that is related to layout is sometimes when executing lots of command, your layout might break. In such case we have to execute this refresh command, so that will work. Since our layout is perfect for now, so we didn't see any effect. Okay, now let us jump into the actual debugging part. So the very first thing that we will do is setting the breakpoint, and most of the times it will be the main. So let us do that, break main. So you can see the breakpoint has been set to the main on line number 24. So now we'll run the program, and in practical scenarios we don't type these commands entirely. So for run the shortcut is R, and for continue shortcut is C, for next for step over or the next the shortcut is N. So for all those commands the prefixes they have some prefixes which will also work. So I will be using those shortcuts practically. You can also find those things in the manual, or I'll provide some reference links in the description. So let us start the program by executing run command. So our program has been started. Now I want to go to the next line. So for that step over or next, in shortcut we can do N. So one other thing that we might want to do is checking the value of some local variables here. In this function we have two local variables, one is this array and other is N. So in order to check them we can do something like info locals, and you can see both of our local variables here. Now you can see some garbage value here because our array has not yet been initialized, neither the size of the array N. So we are seeing some garbage value here. Now let us go to the next line, and if we do info locals again, now we can see that our array has been initialized. n is still the garbage since this line has not yet been executed. If we do n and info locals again, you can see we can see both the array and n has been initialized. Now now suppose let us take the scenario we have some problem in this bubble chart. We have some problem, or maybe we want to just see step by step how the sorting algorithm works. So for that purpose I want to go into that function. So for that I'll execute stepping instruction, which is executed with the step command. So here now the scope of the function has been changed. So if I do info locals, now I'll see the local variable in this scope, so which is ing are here, but j has not been recognized yet. So if I do next and next, now if I do info locals, I can see the value of ing variables here. So this is also something that we used mostly, info locals. And so some other things related to info is we can see the breakpoints here. Since we have only one breakpoint, we are seeing that breakpoint in main 8 bubble chart line number 24. So that is about in info command. Now let us say I want to know the state of the array as our bubble sort algorithm goes in the different iterations. So for that I might want to set my array as the was point. So that is something that perfectly makes sense. So that is one scenario where we will be using this debugging tool. So let us set that array as our breakpoint. So normally what we do is was and the name of the array, but since this array has been passed as a pointer, we cannot directly do like this. So you can see here, if I do print array, if I didn't mention, print command is used for printing the value of some variables at this point of time. So if I do print I, print j, like that, or print n, we can see the value of those variables. N was the size of the array, you can see 5, ing are 0. So if I do print arr, I cannot see here, I can see that address of the array. But when I was in main function, if I had done this print array, then I would have see the state of this array. So in this kind of scenarios, we have to dereference the array. So for that, asterisk, name of the array, @ and the size of the array. So this command we have to use. Now we can see the state of our array. Now since I want to see the state of array in different iterations, I'll set this as the was point. So was asterisk arr @ 5. So was point has been set, you can see here. Okay, now let us go to the next. Now you can see here, as soon as the value of array was changed, we saw some old value and new value of the array. So the state of our array has been changed. So if I do next and like follow the execution step by step, I can understand how the array is actually sorting the elements. So this is the one use case of debugger, not only for finding problems in the code, but for having the thorough understanding of the code. That is another important use case of debuggers. And suppose another thing that we do mostly in case of loops is, suppose I want to just track the state of this array variable in different iterations without going through these intermediate steps. So for that, what we will do is set this loop line as the breakpoint. So this line 6, suppose if I set it as breakpoint, break line number 6. Now what I can do is, if I do continue with C command, you can see that all these intermediate lines are executed directly and are not paused. So this might pause at the end of this loop. So if I do C command again, so I can directly go to the next iteration. So if 1C, 2C, so that will take me to the next iterations. You can see that our sorting is in progress, 3 2 4 5 1 3 2 4 1 5. So you can see that 2 2 1 4 5, and in next few rounds it should be sorted 1 2 3 4 5. So now our array has been sorted. So was point to deleted because the program has left the block, which its expression is valid. So now we have came out of that function and paused on line number 28. If I do next, now that we can see the sorted array will be printed 1 2 3 4 5. Now you can see our layout has been broken due to lots of commands here. So in such case we can execute a refresh command. So this will reset the layout. So that is how we do the debugging using GNU GDB. So that's it for today's video, guys. Thank you so much for watching, and I'll see you in the next one.